properties of definite integrals continued, just finishing off the last questions because the board broke down and didn't come back to life. Okay, so we were in the process of integrating a definite integral. So what's our lower limit?
-1.
Yep, and our upper limit. Already like this one, yep. Our function is a quirky kind of function.
It's a composite.
Composite?
Composite.
It's a composite. And Bella, what is the baby function? Yeah, and what's nice about that? What kind of function is 6t? Is it a quadratic? Is it a cubic? It's just linear. Yep. So in our course, there's a special method we know in our course for when we integrate a composite where the baby is a linear. What we do is we integrate the mother and we find the derivative of the baby and we multiply the integral of the mother by the reciprocal of the derivative of the baby. So that's just a method from a previous lesson, from like lesson 3 or something like that.
The integral of the mother by the reciprocal of the baby?
Yeah.
Okay.
Oh, interesting. The integral of the mother is multiplied by the reciprocal of the derivative of the baby.
Okay. Reciprocal of derivative of the baby.
So yeah, this was from a few lessons ago, but like you might have forgotten it by now, so that's fair enough. So the integral of the mother is e to the u, because integral of e to the u is just e to the u. The baby was 6t, so the derivative of the baby was 6. So the integral of the mother has been multiplied by the reciprocal of the derivative of the baby. And when you do 1/6 times e to the u, you get eu over 6, and then you just sub back in the u, e to the 6t over 6. So now to find the definite integral, we're going to sub in, remember you sub in the top upper bound, sub in the lower bound, and what do you do with those two answers? Subtract them, yeah, you always subtract them.
Upper bound, subtract lower bound.
Yeah, that's totally it. Okay, nice. So let's do that. And we were trying these ones non-calculated. We've got the birds there. So now when I sub things in, I might do it in blue because my writing's getting all messed up together. When I did it non-calc, it was a bit of messing around. So plug it all in to start with. Plug in the upper bound. E to the 6t is e to the 6 times 1 over 6. And then as Paige said, it's always subtract.
You know that we finished this one, right?
Oh no, we hadn't quite finished this one. It looked like we had, but we
Oh
hadn't.
yeah, never mind.
Like, it's probably because we can...
e to the 6.
-6.
Oh, I forgot that. Sorry, yeah, thank you. Yeah, thank you very much. Otherwise that'll look messy. 6 times -1, yeah. Or you can go straight to -6 if you want. That's okay, because you probably realise what that is. I'll do the next bit in red, which is e to the 6 over 6 minus e to the -6 over 6. That might be kind of an okay way to leave our answer, but it might not be the best way to leave the answer too. So just in case they do kind of like, that could be totally okay. I'm going to circle that. I'm going to circle that to say that's okay to leave it like that if you want. If it said no negative indices or something like that, we might have to do something with it.
So that's it?
Yeah.
Well, we did that.
Okay. Oh, did we? Oh, okay, sorry. Maybe not everyone got it written. Yeah, so Kristen, maybe not everyone got it written down before the board started to play out. That might be the case. So that's one way you could leave the answer, just in case they do mess around with it a bit more.
Just put it at the bottom. Put this at the bottom.
What was I thinking about? Oh yeah, you can combine it because they've both got a common denominator, don't they? So another way they might write it as e to the 6 minus e to the -6 all over 6. Just showing you that there's different ways that it could be written.
So then couldn't we do 6 plus or subtract 6, I'll just give you 0? Or no, we just leave it like that.
Yeah. If they said no negative indices, you might need to change this into positive indices. So the question didn't say no negative indices, so both of those are okay. But if they did say no negative indices, what could you do?
No, that's not what I was asking.
Yeah.
Because I was saying since the base is both e, wouldn't we just do 6 subtract 6, it would be e to the 0 or no?
Oh, that's when you, like, say if you do e to the 6 times e to the
okay,
yeah. If it's times or divide, then you can do like exponent laws. But there's no special exponent laws for plussing, adding, and subtracting in between the two terms, unfortunately.
So you just leave it, okay.
Yeah. So if it said no negative indices, you have to kind of change it. So e to the 6 over 6 is fine. That's got positive indices. Yeah. there. So e to the 6 over 6 is fine. But what about e to the minus 6 over 6? How did you rewrite that one?
Put it at the bottom.
1 over
Yeah, good.
e bracket e over 6 to bar 6.
Yeah. So is that what you meant? And don't forget the little 6's there as well. Yep, 6. E to the 6, yeah. You can totally write it like that. See negative exponents? You put one over that number with a positive exponent. So e to the negative 6 is like 1 over e to the 6. And then times 1/6 as well. So that kind of thing. So they might write it like that. It's also possible. They might also take it further and try to make a common denominator of 6e6 and then combine the numerators and all that kind of rubbish. So just showing you that they can do that. Do you want to try that?
No.
I'm gonna say sure.
Yeah, I'll just do it for fun. You don't have to write it down if you don't want. I'll do it in blue, purple down here. SEA. So if we want a common denominator of 6e6, what do we need to times the top and bottom by here?
Just
E to the 6, yeah. And out of interest, what's e to the 6 times e to the 6? You're mentioning it before, Krista.
Oh, e to the 12.
E to the 12, yeah. E to the 12 over 6e6 minus 1 over 6e6, which would equal e to the 12 minus 1 over 6e6. And then things are just getting out of control at that point. So it's kind of like, so I thought I'd
How
just show
did you
it.
get to e to the 12?
Oh, that one. So what I did was, if you want to go, we times the top and bottom by e to the 6 over e to the
Oh,
6.
because you need the same denominator.
Yeah, yeah. So if you want to, like,
I like the first answer.
the first answer is lovely, yeah. Yep, I love that. Or any of these ones. So that's kind of what we did. So I'll just kind of show you those ones in case any answers say show that equaled something horrible like that. Just realizing that you could do certain things. It's good to practice our fractions and exponent laws and stuff anyway. If they didn't say no negative indices, you can just leave it like that. It's fine, like that or like that. If they said positive indices, you'd need that. If they said show that it equals that, just pointing out that you could. And like for me, if I saw show that it equals that, I'd be like, what? And then I'd get that, and then I'd just start messing around with it. I'd start to experiment with that, get my normal answer, experiment around with it a little bit, and then I'd slowly get to that.
I would just make it
Yeah, exactly. So feel free to, like, you know,
What would you think
not
it
doubt
was?
yourself.
And then if that was the final answer,
Yeah.
like, so that I would think
The
if I got
question said,
that,
show that it
I would
equals
have said
that.
it was wrong.
Yeah, exactly. And like, I wouldn't have that answer and realize, hey, that automatically that becomes that. It's through a little bit of just what I call blind experimenting. A little bit of blind, like, you know, just trying a few different things. But that'd be pretty yucky if they said, show that it equals that. Because the question's hard enough as it is, to be honest. But I thought I'd give it to you just in case. But if they don't ask you to do any of that rubbish, then this answer here is just fine.
Yes, Lauren.
What on earth is this one down here? Composite. Oh, yeah. Well, what kind of function is this one here? Composite function. And what is the baby? Is that a linear?
Yeah.
Yeah. So when it's a linear, in our course, there's a special short method. Remember, we take the integral of the mother.
And the reciprocal of the derivative of the baby.
Yep. And what do we do with those two things?
Multiply them together.
Yep. Yeah. Good. Okay, so let's make a note of it if you've got any space at all. It's a composite function with linear baby u. So therefore we use this little method, and that's the case. I'm going to colour that, sorry. That's off already. So what I first do is I define the mother in blue, and I write the baby in green, and I find the derivative of the baby in red. I do all that on the top line. It's my little method, so I like to I find it comforting. Okay, so
Can I just check? Because I don't know if I did this right. It's
I do it.
16 for the winter or
I got 10. But I could have done it wrong, because I've got all sorts of horrible crossing out, and I did it at you know when you do it at like 7:30 p.m. on a Friday, things don't go well. So don't necessarily think you've done anything wrong because 7:30 p.m. on a Friday, I make all sorts of
No, I
reasons.
just.
7:30 p.m. on a Friday, you're doing math.
Yeah, that's you shouldn't be doing it then. That's right. 'Cause things like this happen.
Wait, 7:35 was late on for Friday or?
Yeah,
Yeah.
Friday evening. Like after end of the week, you're tired already, and
Oh, I did.
I should have done it. I should have
Friday?
gone home and done it Saturday morning.
I'm not big.
Would have had so many mistakes. So what's the mother? Let's do the mother in blue.
U to the 3.
Yeah, you to the 3 kids. Oh gosh, look at that. You do the 3. I do the baby in green. It's my thing. What's the baby?
2W subtract 1.
2 subs. Yeah. And what's the derivative of the baby?
2.
2. Yeah. See, the good thing about a linear, it's just a number.
So we need to integrate the mother?
Yeah, that's what I like to do next. So the integral of the mother, because otherwise if I don't make a point of doing this, I forget it sometimes. That's just me. If you don't forget it, then don't worry about writing out integral of the mother. Just go straight to timesing it all together. What is the integral of the mother?
Is it U4? You get 4?
Yeah. U4 over 4, yeah. U4 over 4. If it was an indefinite integral, you'd have to have plus c. But because these are definite integrals, we don't deal with plus c's. We're just going to sub in numbers and get an actual number answer. Integral of the mother. So now we've got to times the reciprocal of the derivative of a baby. 1 over 2. Got to times that by the integral of the mother. 8. Okay, U4 over 4. Whoop whoop. Okay, times that. What do you get? U4 over? 8. Good, yeah, U4 over 8. And then in my final thing on this line, I just sub in the baby. So sub in the baby, you've got 2W. Yeah. Power of 4. Over 8. And now I've got to evaluate it by subbing in those numbers. So that's all that messing around.
Just it?
No, now I've got to sub in the numbers. So now I'm gonna just show you the notation. Remember I put in the big square brackets?
Oh, I forgot about that.
Yeah, exactly. I forget all that stuff too. So 2W minus 1 to 4 over 8. What's our upper and lower limit?
2 and 0.
Because all the work you've done seems like so much work already. You think, hey, yay, it's over. Not.
So
We've
we
got to
times the reciprocal of.
the derivative of the baby.
Yes.
Yeah, that's why I like to work out these 3 things, like the
The
mother,
derivative of the
the
baby.
baby, and the derivative of the baby. Then it's 1 over the derivative of the baby
Yes.
times the integral of the mother.
So if the derivative of the baby turned out to be a fraction, then you just have to like flip it.
Yeah, exactly. Like if you got 2/3, you would get 3 over 2. That's exactly it.
As what?
Like say if your linear was 2/3 x minus 4.
Oh, okay.
So the derivative of the baby would be 2/3. So the reciprocal of the derivative of the baby would be 3 over 2. Yeah, and that could definitely happen. I haven't given you an example like that, but that could totally happen. And then like Paige said, we work out these 2 numbers and we subtract them.
I don't like this.
Messy, eh? So what's 2 times 2? I'm being a bit lazy because my pen. 4.
Subtract 1.
And you'll subtract 1, yeah. So let's do 4, subtract 1, which is 3 to the power of 4. Over 8 minus 0. Okay, negative 1. I think I'm running out of space, so you could show a little subby bit, but I'm kind of getting my pen's just not neat enough. So 2W minus 1, Sarah just pointed out already, is 3 to the 4. And then like Paige said, you always subtract the lower bound subbed in, which was what, negative 1 was it?
I got 10.
And then you start to work out those numbers.
Is that over 8?
Oh gosh, thanks. Over 8, yeah. And the reason why it's not over 4 is because you had to times by 1/2 before. Well done. And what is 3 to the power of 4 equal to?
81.
81, good. 81 over 8 minus negative 1 to the power of 4. So, yeah. What does that give us?
80 over 8. Which is 64.
And
That equals 64.
64?
Mm-hmm.
You're a cool kid.
This is pretty hard stuff though. So good on you for trying it yourself. That's very brave. So these were all nice. These were examples of the previous lesson where we had composite functions with a linear baby. Do you remember there also being composite functions where they were the product of a composite function and the derivative of the baby were times together?
The product of the composite function.
Yeah, composite function had been times by the derivative of the baby.
Wait, so would the product of 2 w subtract 1, 3 would be when we simplify that? That's what you mean? The product?
Oh no, I'm talking about this one.
No, okay, that's
I'll try to find the page where it was. I'll just try to find the page where it was. Where was it? Goes before these, goes before the battle. These ones, here you go. So do you remember being back to whichever page this was, where we did some horrible proof? Another type of quirky function which can be integrated in our course is one where it is the product of a composite function and the derivative of the baby function. These were some examples. Here's the composite function. What's the derivative of the baby?
the derivative of the baby?
Yeah, what's the
That.
Yeah, it's that. So this is an example of one of them. Here's the composite function. What's the derivative of the baby?
That.
That, yes. So this is an example of one of those. Here's the composite function. What's the derivative of the baby?
X.
Well, half of that, so you can do it.
Yeah, that was a dumb one that you didn't understand.
Yeah, it's a hard one. So here's the composite function, 1 over this. What's the derivative of the baby?
That.
That, exactly. So
You still a major one.
these are actually even easier. So these are actually super easy. They're easier than the ones we were just doing. All you do is, wait. All you do is you just integrate the composite function, and the derivative of the baby kind of ends up being cancelled out. So there's no multiplying it by 1 over the derivative of the baby. You don't. It just can't. It just kind of disappears. And remember, I did some proof, and you were like, "Yay!"
No.
And then, and then we're just like, "Now you believe me." So it's actually less work. See what? Here was a worked example. So here was. Where is the actual question? Oh, here was the thing. Find the integral of this. The derivative of this is what it's being multiplied by. So see, all we did was just write the composite function, u to the 5. It's u6 over 6. Plug in the baby. And if it's an indefinite, you plop a passy on the end. Notice it's like you don't do any 1 times 1 over the reciprocal of the derivative of the baby. It's like the other one, but there's no 1 over the reciprocal of the derivative of the baby. Because in the proof before, we kind of proved that, remember the dx, the 2 dx's got cancelled out? So in the proof, the 2 dx's got cancelled out, so it ends up just being that du. So integrate that with respect to u. But if at this point, you can just accept it if you like. And we just need to remember the method. Just remember it's easier than the composites with the linear baby. It's even easier than that. There you go. All right, so this is, we need to write out what kind of function it is. Let's do that. So it's the product of a composite and the derivative. What pages were I just looking at? See page. What page were we just looking at? That where I saw that. I should have looked, made a note of that. Let's see if I can find it in here. 17?
That was page 10.
Was page 10? I thought it was 18. What are you sure? Which page was it?
Not following.
It's 12.
It was page 10? Okay, page 10.
Bro, we was just looking at
It's
Yeah, see page 10. So you might want to make a note of that. So when you look at this and go, oh my gosh, what is going on? You might I might just remind you that this kind of stuff was kind of all proven and examples of it made on page 10. So these are nice. All you have to do is define what is the mother function, the mother, in terms of the composite bit. How can you rewrite cube root?
1/3.
Yeah, u to the power of a third. So I've got u to the power of a third, like rather than write it as a cube root of u, write it as u to the power of a third because that's easy to integrate. We need to, in a way, like, you know, you don't, what is a u? Yeah, we should write out what the u is. What's our baby?
2x squared plus x.
What's x, yeah.
Not for me.
So we don't actually need to work out the derivative of the baby.
It's right there.
Yeah, because the derivative, you just want to just double check, is the other thing the derivative of the baby? Just double check it. Like 2x squared becomes 4x plus 1, yeah. So just double check that it is the derivative of the baby that it's being multiplied by. Maybe let's kind of separate these. Okay, the product of a composite and the derivative of the baby. See page 10. These are nice. We need to now find the integral of the mother. The integral of the mother. Integral of the mother is, what is 1/3 plus 1?
Wait, so the mother is 1/3?
U to the power of a third.
Yeah.
Yeah, u to the power of a third, yeah. And u is 2x. So see the cube root, rather than write the cube root. So what is, yeah, the integral of the mother?
4/3 in my exam, if I write like mother function, they're not going to occur, right?
They won't care.
The mother function.
If it's just in your working out and they can see the notation, like if you're just doing this to keep yourself on track, they'll be looking for the notation and that kind of thing. Quite often mother function is something that they might understand, but the baby, they might go, what? So sometimes people call it baby u or just u. So the integral of the mother is, yeah, u to the power of 4/3, good. So if you can't see what that is, that's u to the power of 4/3. Remember, you always divide by what the new exponent is. And what is that simplified? Written nicely.
3. Did you do the no? Times.
That kind of thing. Some people, you could have written 3u to the 4/3/4. That's also okay.
Yes.
So just saying that, remember dividing by 4/3 is the same as like timesing by 3/4. I just personally found it easier to write it that way rather than 3u to the
Why do you
4/3
find
over 4. And then subbing in the baby is going to be easy too when I write it that way.
Okay, maybe this is why
Wait, don't we need to find the derivative of the baby?
With these ones, no,
Or
yeah,
like,
give it to
we
it.
just
Yeah.
write it down? Just for...
Sometimes I work out the derivative of the baby just to prove that it is the other thing,
Okay.
that it is the other
Do
factor.
that.
Yeah, so feel free, sometimes I write it down just to be in the habit, and then the whole point of it is just to prove that that is the derivative of the baby, 4x plus 1 is the derivative of the baby. But we don't use the derivative of the baby in anything, because in that proof thing, it proved that the derivative of the baby kind of, in a sense, kind of cancels out.
Wait,
In a sense.
wait, how did you derive the baby? Because I'm not getting 4x plus 1. Isn't the derivative going to be 4x plus
1.
1?
Yeah.
1.
Oh yeah, if it was 5x, it would just be 5. Oh, you're thinking integrals. You're thinking of integrating.
It's in the imaginary
Oh,
one.
yeah,
Yeah.
okay, sorry.
Yeah, that's a hard thing. Once you've learned integrating, it's very easy to get muddled between the two.
But isn't derivative, don't you make it negative? What? We were into.
We're deriving.
So like you bring the power forward.
2 times 2 is 4. And 4, and then subtract 1 from the
Wait, so
exponent.
it would be 1x to the power of -1.
Close. 1x to the 0.
Oh, that was.
Oh!
Yeah, yeah. Which is why it's just 1. Because x to the 0 is just 1. So we just don't bother to write the x to the 0. Okay, so we might want to rewrite it with the baby subbed in now. Let's sub in that baby. So baby, 2x squared minus plus x, sorry. It's a lot of messing around, isn't it? The 4/3. Oh, and this one was hideous. This is the one that kept me going for a long time.
Great, you just
So I hope but what I had to do was, it's okay if the numbers worked out, but the numbers just weren't working out. I kept getting an error message, and it's all because I had to mess around and change some numbers.
Well, how are you getting an error message?
I think because I was ending up with the square root of a negative. I was ending up having to try to find the square root of a negative, which remember is like doesn't exist.
Miss Melanie, do you make up all your classrooms?
I kind of, no, I get them still from the book and sort of from past papers, but because you know you don't want to use the exact same ones as the book, so you want to kind of make them a bit different, something a bit different, because it's a bit boring if I give you the exact same ones from the book and then you do them. I personally don't like that from a student. I don't like doing the exact same ones.
I want to stay here and get
You are nice me right now.
do
And then, but then the problem was the numbers just weren't working out on this one. That's why I always have to sit and do them. Okay, so that's the thing. And now what we've got to do, if we just had to find the indefinite integral, this would be wonderful. We would just write this bottom line with a plus c on the end. But I didn't want that. I want the definite. What's our upper limit and our lower limit? Zero and negative 1. Okay. Yeah, and that's what I had to mess around with. I had different limits and they were giving me errors, which was painful because it meant that I had to take the cube root, or this. I initially had square roots, and you can't take the square root of a negative, but you can take a cube root of a negative. So that's why it all worked out.
That's very true. That's the truest thing about her.
Okay, what's our, so what is it
I
again?
can't see this.
Is it 0 and negative 1?
-1.
Yeah, because I've changed mine so many times, I can't see what I changed it to. So now we're calculating this bizzo. We're 0 is nice. What do you think's going to be? What do you think's going to pop in when we do 0? Yeah. So if you want, like, let's double check that. So we're going to get 3/4. 2x squared plus x, 2 times 0 squared plus 0 is just going to give us 0. Minus. But the next one's going to be a bit awkward. So 3/4. Now let's do it in, let's work this one out properly. 2 times negative 1, because otherwise things can go wrong for you.
That whole thing is there. I can't see.
2.
Boo-hoo.
She said, well,
Boo.
Miss Melanie, look out for sleepover and you're invited.
Are you guys having it before you graduate?
You're having it here.
I know that.
The teacher know? We just
Yeah, we
like,
talked big money.
Loves the idea.
Yeah, actually.
Yeah. Because, I mean, we consider her one of the two teachers, but everybody knows that one.
we're still recording. Okay, so.
I have there's a.
Okay, so this is a bit tricky, this stuff, so maybe let's work out the blue bit first.
Miss Melanie, I don't know what speed.
I know, yeah. So I would say hold off for now, and then like maybe just see if you can find a way to kind of write it quickly on the end. So what is using ZMath? Is this answer negative 2 squared? No, what should you do instead?
It's negative 1 squared.
Yeah.
2 subtract 1
1.
is 1.
2.
No,
It's 1. It equals 2. The whole thing equals 2.
It's 1.
Yeah, what does it equal?
2.
What does that thing equal?
2.
Subtract 1.
Is 1.
1, yeah. So overall, yeah, we've got 1. And that's why I had to mess around till I got a nice number, because otherwise I was getting like errors. And also, I initially had an even root down here, and you can take the odd root of a negative number, but you can't take the even root of a negative. It's not allowed in that. So that's why it was giving me error messages. So I had to change it, so I was going to end up with a odd power. So 0. Yeah, obviously, 0 to the power of 4 over 3 is going to be 0 times 3/4 is going to be 0. So now we've got to work out 0 minus 3/4 times.
Do you spread the 0?
Oh, you might want it just to be, like, you know it's going to be negative in the end. So notice, where does the 3 go? Here or here?
The last one.
The left one, yeah. So the cube root of 1 to the power of 4.
Oh my goodness. That's not very
Zero.
nice, Paulina.
I think so.
What's the cube root of 1?
Cube root of
So 1 to the power of 4 is? 1, yeah. So 1, so that's 0 minus 3/4 times 1. So our answer is negative. So that's what I had originally. Thank goodness, yes.
I had a question.
If you run out of space, feel free to summarise that somehow. You don't have to write every step.
What I was curious about is why we didn't, what did happen to the 4x plus 1?
What happened to the 4x plus 1? Oh, I'll just let people write that. On page 10, I'll show you, there's a little proof. It's either on page 10 or the page before. There's a little proof of why that 4x plus 1 kind of cancels out. Yeah. So I just did a little proof with you, but you don't need to memorise the proof, you just have to accept it. Do you see the bit where the dx's got cancelled?
Where?
Down the bottom of the proof?
Is this on the analytical quirky function?
Yeah. And like it says, prove it, and let me prove it to me or something. And see down the bottom, the dx's got cancelled out in the proof, which means the integral of the u function, du, with respect to u only. Whereas normally it's du dx. Yeah. You just have to identify that the thing that was multiplied by it was the derivative of the baby.
What if it was like a 4, it would just be like, say like it was just like it didn't have like a 4x, or something, it was just like a 4 was the derivative, maybe you would just still cancel it.
You could, but that's also the properties of integral stuff. Like, remember when there's a factor? I'll show you. Oh gosh, and these things, because the board kicked off. Did you see back here? Shh. Oh, you'll see here, Bella? Then you'd probably get something like this. Guys, shh. 4e to the x is like 4 multiplied by the integral of e to the x. Then it, like, you know, you could do that, but this is simpler. Like that little properties of integrals are simpler. Yes, please. Yeah, because while you're doing that, I'll just stop this one before we start the next one.
I wonder what it is.
So I'll just